Hello everybody. Thank you for joining me today for this webinar. Today we're going to be discussing Legionella and the risks associated with Legionella disease. Over the past 3 years in Quebec and Ontario, the cases of Legionella hitting the population has actually doubled, like I said, in the last 3 years. So this is something that we're going to have to live with as time moves on. And in this presentation, we're just going to go over a brief overview of what we're going to how to try to mitigate the risks, what to do to stop it, how to keep things clean and try to keep the population safe. This material could be a lot longer. Like I said, it's an overview. So we're just going to be just going over some of the details, some of the minor details, and you can feel free to ask some questions online. Our technical team will be available for you to answer if you wish any of the questions and get back to us. So essentially, what is Legionella? Well, it's ubiquitous. So it's everywhere in the environment, in the water bodies, and especially North America, Europe, mostly in freshwater lakes and in rivers. And it's usually found in very low concentrations, but it's pretty much everywhere. So it's not as if we can sterilize the environment and get rid of Legionella bacteria. Like studies have shown, it's about 80% of the lakes and rivers you can find some in it, even though, or albeit in very low concentrations, but they're everywhere. Where it loves, it proliferates and grows mostly between 25 and 45 degrees Celsius, but its ideal temperature is actually at 35 degrees Celsius, which often is where we're at in cooling waters, in cooling towers. So this is why it's become a real issue for our treatment programs. There's something to note that where it really likes to grow, or when it really proliferates a lot in the cooling towers, it likes to be around other microorganisms. So if there's protozoa, amoebas, or algae, that's when you really get high concentrations of Legionella, or you can get high concentrations of Legionella. So we're not just, when we're trying to attack the microbiological activity in the cooling systems, we're not only specifically going after Legionella, we're going after the whole flora, but we are able to measure Legionella directly. One of the things that they're pretty particular about, or pretty adept, is the fact that they're hard to kill. They can actually go into a hibernation mode at high temperatures, low temperatures, high or low pHs, and they can actually go into a dormant, sort of a quiet or a dormant mode, even when there's low food, very low food. So they're pretty resistant as far as activity or lifespan. They're pretty hard to kill. So you have to take some serious steps to take care of that. So, and today, like I said, we're talking about cooling towers specifically, because there are some other systems where it could be found. But the bacteria, how it gets in, well, they come in through the makeup water. And a lot of people are sometimes surprised to know that it comes in from the makeup water, because we think, our cooling tower is using city potable water. It's perfectly clean. The reality is it's not perfectly clean, and sometimes Legionella can come through. And that's where by far the most sources of Legionella, or the source of Legionella contamination come from, is from the makeup water. Obviously, if your cooling tower is using lake or city water or lake or river water that's just filtered, in that case, you'll have more of a tendency or more concentrations to deal with. But it's mostly from the makeup water. There are some very rare occasions where you can get cross-contaminations from other cooling towers, like your neighbors or other buildings or other plants that are within striking distance that are not being treated properly. There are some rare occasions you can get some cross-contaminations, but it's not the most common part. Other common systems that we talk about, or that we're not talking about specifically today, but that are sources of Legionella bacteria contaminations, they include hot water domestically. So in hospitals, in homes, in gyms, and things like that, the hot water system can be contaminated. It could be from the fountains, the decorative fountains, the humidifiers, spas, all these types of things where they create small mists and things that are actually real identified and real sources of contamination. So, but today, like I said, it's just a standard thing. We're just talking about cooling tower. There are, and the way it works, the common point of inhalation is breathing in. So it's through the airways, where you breathe in small mist into deep lungs, and that's where the bacteria proliferates in your lungs. There is no real risk of human-to-human contact, so it's not an issue for that part. So, what are the symptoms of Legionnaires' disease? they're often confused with the flu. They're very similar to the flu. You can have a headache, fever, tiredness, dry cough, difficulty breathing because it's in the lungs. And yes, in these times it does sound like COVID-19, but it's completely different. There are two main types of disease associated with Legionnaires. There's the more common one called Pontiac fever, which has a high rate of contamination, or somebody exposed to it will get sick, but it's not lethal. It'll last for a couple of days, 2-3 days, and it'll seem like a normal flu. The main Legionella disease will only affect less than 5% of the people exposed, but those that do, the mortality rate's a lot higher. It's about 10 to 15%. And that varies depending on the person's constitution and their immune system. So those are two main things about the Legionnaire's disease. So the people that are most susceptible are the ones that the elderly and those that are smokers. So because of their lungs are in a weakened state. So how does someone become sick? What's the method of transmission? So it starts with Legionella source. So cooling water becomes contaminated from the raw water. There is a mechanism of concentration, whether or not it's proliferation of algae or bacteria, where the Legionella count goes high. Then you have the transmission of the liquid water to the air, which is part of a mist formation that happens. And that mist, which contains the Legionella bacteria, would get inhaled into the lungs. So those are the three steps that need to happen. You need to have a concentration mechanism. You need to have the bacteria in a vaporized liquid mist drop, and those droplets need to be absorbed and inhaled into the lungs, and that's the method of transmission or of somebody becoming sick. So all the efforts we need to do is look at one of those three or all three of them together and see if we can not reduce the risk by controlling some of those parameters. So the first thing is, what are the factors that increase the influence or the risk of infection? So the first one is general high microbiological activity. So like I mentioned before, Legionella it likes to be around other bacteria, protozoa, amoebas. So one of the things you need to do is control the whole flora, the whole activity. And that's, you can do different types of tests for that, aerobic tests, it could be ATP testing, there's different ways of looking at that kind of stuff. There are other parts is you need to reduce fouling. So if there's a lot of silt in your cooling tower, if there's a lot of dust, dirt, scale laying on the ground, those act as places for harboring bacteria, and that's where they grow. And those are the types of things we get to remove of. So any of those things all contribute to increased microbiological activities in the cooling tower. Other factors that we need to manage are dead legs or intermittent operations. So stagnant water, bacteria, generally speaking, like stagnant water. They have a lot of time to grow. They can, especially if they see some nutrients laying around in the water or some other bacteria, dead bacteria, or some organics, oils and things like that. Intermittent operation and dead legs are beautiful places for bacteria to grow. And what they do is they create very high concentrations of bacteria in the rest of the system, which just help bacteria and Legionella grow. One of the best examples we have is if you have a cooling system for a standard HVAC system for your building, and you have 3 or 4 chillers, but the temperature is not so hot outside, so you're only running 1 or 2, so you've got 1 or 2 that are on standby. Well, those represent significant risks for being stagnant water and need to be managed to reduce the risk. So now that we know some of the risks, let's look at some preventative measures to help mitigate those risks. So like I said before, stagnant water is an enemy. So promote the circulation in the piping in the equipment. Avoid having heat exchangers that are offline. Ensure that the contact with the biocides, when there's a biocide that's being injected, ensure that the whole system sees and is exposed to the biocide. Time the biocide injections with automated circulation pumps or valves opening them up. Make sure that the proper treatment is reaching each of those layers in each of those piping systems. Avoid stagnant conditions for more than 2-3 days at least. So in other words, a long weekend is considered a long period for stagnation. So schedule circulation times. Every noon or every midnight or 10 o'clock, have the circulation pumps turned on for an hour and let that go through the system. Make sure that you avoid those stagnant conditions. And if for some reason you do need to have stagnant conditions for a long weekend, well then when you have a startup, make sure you proceed with a preventative disinfection before startup. Those are really significant actions you can take to reduce the risk for people getting sick for Legionella. So it's literally impossible to eliminate all the risks. So what we're trying to do is mitigate them and reduce them. At the basic level, what we need to do is ensure that you have in place a proper scale and corrosion program for your cooling water. Make sure it matches with your water qualities, your operating temperatures, your volumes, your metallurgies. That's really important to do. It has to be at a basic level. You need an effective water treatment program for that. Use the approved biocides. So in Canada specifically, we have to have a biocide that's been approved with PMRA, pesticides management regulations, and that has to be done properly with the right conditions, which include contact time, pH, temperature, metallurgy. So those are really important things to do. And always use a biodispersant. It helps keep surfaces clean. It takes away the places where bacteria can hide. And those are three basic ways to manage, at the basic level, Legionella. The other part we want to talk about is have a good control of the water usage. So manage your cycles of concentration, how much water you're bringing in versus how much you're blowing down. Typically, we'd want these to be automated. There's some very inexpensive equipment, very high quality equipment you can use to manage those cycles. Test, test, test. You need to test for bacteria. You can test for total bacteria count, but you can also test for Legionella specifically, which you cannot usually do at your site, but you can have an accredited lab to do that for you. But you need to be testing. Without testing, you don't know what's happening. You can only guess. So that has to be part of your program in place. Have in place an action plan for positive results. Okay. Because there will be positive results, and it's how you manage those levels of contamination are important. Sometimes they're very minor, sometimes they're important, sometimes they're critical, and those action plans are different depending on how the concentration you have. So have those in place, and it's very important to do. So with regards to the two tests, or the tests that are available for Legionella specifically, there's a lot of material, and there's enough material to have 3 or 4 webinars just on the testing protocols. But at a basic level, there are 2 different types of tests. There's the culture test, which is essentially a petri dish, and those will give you results within 10 to 14 days of viable bacteria. The secondary test, or what I consider maybe probably a more important test, is called a PCR, so quantitative PCR. Now, it can also test for living bacteria, but it can test for dead also, and there's ways to test for both. And sometimes it's important to know if you have a lot of dead bacteria, because if we have an analysis and we see there's a lot of dead Legionella, that means we had a very high contamination of Legionella. So it's almost just as important to know how much dead and how much is alive. But one of the main advantages of the PCR is that you can get the results within 12 to 24 hours. So those are significant time savings to do an action plan versus waiting 2 weeks for a culture test. Some of the other basic things that need to be done for a cooling system that help is just basic housekeeping. Make sure things are clean. If you see accumulation at the bottom of the cooling tower sump, clean it up. If you see that the mist eliminators are broken or they're fouled with collection of garbage bags carried in the air or something, make sure you remove them. Some basic housekeeping is important. Inspect the cooling tower. Go upstairs, go outside if it's on the roof. Have your maintenance people go and inspect, make sure things are looking like they're supposed to, that water's not being overflowed onto the roof, or that the spray nozzle or distribution channels are clean. Those are all real important things to do at a basic level to mitigate these risks. Major importance is to clean and disinfect the cooling tower systems at least once a year. That includes the basin, the fill, the distribution systems, the heat exchangers, most of the piping if you can, or to dryness when you lay it up. Those are basic levels you need to do every year. So as I mentioned at the beginning of the webinar, this is a very brief overview of the Legionella bacteria and the disease associated with it. But there are a lot of some excellent documentations that are available, some guidelines for your reference that are available online. One example is the MD 15161 from the Canadian federal government. You've also have ASHRAE guidelines from the standard 188, and there's more. So feel free to download or purchase those online, or you can contact us at info@magnus.ca. We have a lot of experience. We're experts in Legionella mitigation. And thank you for joining us. Please send your comments or questions to our link, and look forward to our next webinar next week for filtration. Thank you very much for watching. Have a good day.